ගාන භාගයට හදලා සාමාන්‍ය විනාඩි 5ක දුර ඉවර කරන් තියෙනවා. ලයිව් දාලා තියෙන්නේ. Next question number 8, 1989. Good morning, children. කවුද ඉන්නේ? නම් දාන්නකෝ බලන්න. Right, we were discussing question number 8 in the tutorial. That's 1989. We did it only halfway. The question is, last part only we have to discuss. You're projecting a particle at an angle. It's a golf ball. It's struck at speed u at an angle alpha with the horizontal, and it lands at point A. It lands at point B at a distance r, horizontal distance r. We have proven that r equals u square over g sine 2 alpha. Further, we are given the minimum distance that this can fall at the same horizontal level, and also the maximum horizontal distance. So the given R minimum is √3 over 2 u square over g. So we used it here and found that alpha equals. First we found R maximum. We have taken R maximum. It's u square over g. So that gives alpha equals pi by 4. Then our minimum is given √3 over 2 u squared over g. So using this, we found the other angle. Good morning, everybody. Abhita, Kusalni, and Yutni. Yutni ne kira mong balang iti. Yutni gitu. Right. So we found that this gives alpha equals pi by 6. But in the question, we have to show that alpha is between pi by 6 and pi by 3. वो प्रश्न उत्तरයක් ආව දැන් සටහන් මම නැවතුනේ. දැන් කියන්න පුළුවන්ද? What is the reason? We are asked to show that alpha is between pi by 6 and pi by 3. For the maximum distance, we found that it is pi by 4. For the minimum, we get it's pi by 6. මේක අපි ඉගෙන මොනවා හරි උත්තරයක් දෙන්න කියලා මම කිව්වේද? Yeah. Got any answer? At 12 today. Right with me. Hari, come on. Home into. Home pada maga. Okay. Can you give some reason? No. Do you remember at the beginning we have proven that for a given horizontal range and for a given speed there are two possible angles, two distinct angles. But for the maximum, of course, there is only one, right? Pi by 4. There are no two. But for any other angle, there is another, right? There is a twin angle, right? In fact, the other angle is the what do you call? Complementary angle of this. So what is it for this? We found that alpha equals pi by 6, but by theory we know that there is another angle. It is the complementary angle of this, which is pi by 3. That's the theory. ඔයගොල්ලන්ට උගන්වපු theory එක මතකද බලන්න පොඩ්ඩක් හරි මම ආයි ප්‍රශ්න ඇහුවේ. උත්තර ආවේ නැහැ. The complementary angle of this. It's equal to pi by 3. So you project at pi by 6 or pi by 3, it will fall at the same this minimum distance, right? You project at pi by 4, it will go to the maximum possible distance. But now how to explain this? Alpha is between pi by 6 and pi by 3. As the particle falls at the same horizontal level, maximum distance u square rho g, minimum distance root 3 over 2 u square rho g, the corresponding angle for this pi by 4, the angle corresponding to this pi by 6. We have to show that the angle lies between pi by 6 and pi by 3. Now how to explain that? Got any explanation? Any idea? So this is a beautiful thing. This is what happens. You project at pi by 6. You project at pi by 6. If you fall at the minimum distance, R minimum, right? Then you gradually increase the angle. What happens? This R, the horizontal displacement R will gradually increase. Will gradually increase as you increase the angle gradually from pi by 6. So you go up to pi by 4. At the pi by 4 angle, you get the maximum horizontal displacement. As you reach pi by 4, so as the angle increases from pi by 6 to pi by 4, the distance, the horizontal distance increases from the minimum to the maximum. You get R maximum, then the angle is pi by 4, right? Then you can go up to pi by 3, right? So you increase it further from pi by 4 to pi by 3. What happens now? After pi by 4, you increase the angle further, it will start to come back gradually because this is the maximum distance. So from pi by 4 to pi by 3, it will be coming back again to the minimum. So that's why you get it's not increasing further and further, it's coming back. So at pi by 6 angle, uh, at pi by 6 angle, sorry, pi by 3 again, when you come back to pi by 3, it will fall at the minimum minimum point again, coming back. So alpha scale, the distance of the particle varies from R minimum to R maximum. Name a name a 5 by 6, 5 by 6 to 5 by 4, it increases, then turn back, and at 5 by 3, it is at the initial initial minimum distance. So alpha stays between 5 by 6 and 5 by 3. That's the explanation, right? හරි. ඔක ලියා ගන්නකෝ. ඒ ගන්න ඉවරද? අපි තව ගන්නකට යමු. Okay, take care. Yeah. Okay. ඔව් ඩයග්‍රෑම් එක මම ඇන්දේ ඔකුලොන්ගේ රෙෆරන්ස් එක ඇත්ත. අන්දිනේ හොඳයි. ඇන්දලා එක්ස්ප්ලেইন කරා. අපි ඔය දෙක විතරනේ ඩිස්කස් කරලා තියෙන්නේ. question number 7 and 8. But I told you to do question number 6 also. දැන් එකත් කරමු. print කරලා දෙන්න. Question number 6. Hari, question number 6, that's from 1980. Last question, 1986 paper. ඔගොල්ලන් මම හදන්න කියලා ඇත්තේ කවුරුහරි හැදුවද? බොරුවට හරි ඕක යන්න ඉන්නවද කවුරු හරි? Question number 6. Did you try at least? කරේ නැහැ? කවුද හැදුවේ? බොරුවට හරි ඕක යන්න කෙනෙක් ඉන්නවද? Question number 6. මම දැන් homework දෙන්න නැතුව මම කරන්නේ. Yeah. දැන් මම විනාඩි කිහිපයක් දෙන්නද? මම විනාඩි 5ක් දෙන්නම්. පුළුවන් දෙයක් කරන්න. Question number 6, right? Tutorial question number 6, that's from 1986 paper. Question number 6, 1986 A-level paper. Hari, පටන් ගන්න කරගෙන යන්න. It's an easy question. ඔයගොල්ලෝ ඔය ගෙදර ඉඳන් කරන අය හොඳට මතක තියාගන්න. මෙතන පන්තියේ ඉන්න විදිහටම වැඩ කරන්න ඕන. හරිද? පාඩම අහගෙන ඉන්න ඕනේ. මේ ගාන හදන්න කොහම හදන්න ඕන. ඔක තියලා ගිහලා වෙන කොහෙද රස්තිය අතු ගාලා කැරකිලා එන්න. එව්ව බෑ. එහෙම විභාගයට ගියොත් බලා ගන්න පුළුවන් මොකද වෙන්නේ කියලා. මාත් එක්ක පාඩම කරගෙන යන්න ඕන. මේක මැත්ස් නේ. ඉතිහාසය හරි බුද්ධ ආගම හරි සමාජ විද්‍යාව එහෙම නෙමෙයිනේ. දැන් අහගෙන ඉඳලා ඊට පස්සේ බෝඩ් එකේ තියෙන දේ පොතේ ලියාගෙන එහෙමනම් ගොඩ යන්න බෑ ළමයි. හොඳේ. මැත්ස් පාඩමක් එහෙම ඉගෙන ගන්න බෑ. මාත් එක්ක ෆලෝ කරන්න ඕන. ඔයගොල්ලෝ මාත් එක්ක පාඩම ඇදගෙන යන්න ඕනේ. රයිට්? දැන් විනාඩි 5ක් දෙනවා කිව්වම ඒ විනාඩි 5ේදී කරන්න පුළුවන් හැමදේම කරන්න ඕනේ. නිකන් බලන් ඉන්නේ නැහැ. මට පේන්නේ නැහැනේ ඔයගොල්ලෝ මොකද කරන්නේ කියලා. ඔයගොල්ලෝ කරගෙන යන්න ඕනේ. රයිට්? Good morning, Sachin. Mogo, para kuna na negative. Paling tu kata. It's very easy. You can do it. Baik na tu kerja ni. Guru te kalpana kerja kita itu inde pak kerja ni. Kerja ni no mai. Kalpana kerja bayar vela balangin na. It's a very easy question. First part is very easy. You can do it. Show me the diagram. Diagram. You are given velocity components. UV in the diagram you can show it. Instead of an inclined velocity, you are given the component, so you don't have to resolve. They are given for free. Nattal dila tin. Man sila ayam dunne. Yeah, yeah, one step further. Yeah. Guru to buy the getting a note. Company can have everything. I am with the okay. ඔකොල්ලෝ මෙතන නැති එකේ පාඩුව ඒක තමයි මට ඔකොල්ලෝ කරන දේවල් තේරෙන්නේ නැහැ. මේ ලේසි පොඩි එකක් ගුරුට බය වෙලා ඔය ඉර වෙලා ඉන්න එපා. ඥාන හදාගෙන යන්න. සක්කාල උත්තරේ එනවා. It's about the horizontal displacement. Usually what we do is apply vertically time t, the time from A to B motion, then use that t to apply a sequence in this direction. Within 1 second, 1 minute, you can get the answer. T squared, you can cancel t. So that gives t equals 2b over g. Speed again, speed again, confidence. Speed again, confidence. කාරණා දෙකකට එකක් අවධානය තියාගන්න අමාරුනාම දෙවෙනි එක කන්ෆිඩන්ස් නැතුණා. ටක් ගාලා කරගෙන යන්නේ කන්ෆිඩන්ස් තියෙන ළමයි. මට පුළුවන් කියලා හිතන ළමයි කරගෙන යනවා. මට පුළුවන් කියලා කියන විශ්වාසය නැතුණාම ලියන එක ගැන හිත බයේ කල්පනා කර ඉන්නවා. ඒක වෙන්න දෙන්න බෑ. විභාගෙට ගියාම එහෙම කර ඉන්න බෑ. ටක් ගාලා කරගෙන යන්න ඕනේ. බලන්න කොච්චර ලේසිද කියලා මේක. ඔයගොල්ලෝ කරේ නැත්තම් R equals U is this. Within 1 minute you can get the answer. So you get UV equals UV equals GR over 2. Right. Try the second part. කල්පනා කරලා තේරුම් ගන්න. මෙතන මේ fielder throws the ball at ground level, right? බිම බඩ ගාගෙන රග බෝලේ වගේ දාන්නේ ආ. මේ ඉන්නේ the fielder. මේ අල්ලන මවුස දෙක නැගලා අල්ලන්න. With the fielder, the cap, yung kadalagan yung pinalaman. Wicket keeper, දෙක නැගලා අල්ලන්න. Okay, you start the next part. One minute keep it then. Pull on that current. Read the question carefully. Try to figure out the task. What do you need to find? Time. Which time? Yeah, total timing in the diagram. What is it? Show me. Yeah. It is the previous one. You already have an expression for that. Ask to find the time to read the food, the feet of the keeper. We already have an expression for that. But this is not the answer. What is the difference? ඕන මෙතනින් ගන්නත් වෙනවා. R equals to T කියලා දාන්න. මෙතනින් අතන තවත් බේසි. We here in this we first apply in this direction and found this. උගලන ඕන ලේසියෙන් මෙහෙම කරන් තිබුණා. B to B motion we want to find this T, right? From A to B. In this direction S equals UT. So that gives R equals UT, T equals R over U. Making an Apula, but this can be easier than that. Even in this, you could have started from that, right? You could start from that, but this is usually what we do to find the horizontal displacement. First vertically, then horizontally. Right. Now, This T is what we need to find. Look at the answer. This R is already there, right? So what is the difference now from the new data? The new data are, they say if the wicket keeper ran much closer to the field, the distance x, ran at distance x closer to the field, the wicket keeper would have caught it at height h, maybe. Say at some point c. That's data. But question is to find the previous p. So using new data, what do you find then? The set of data, new stories. Using what? Using that, what do we find? Use the new data to find what? Oh, here we already have an expression for t. In that expression, r is already there. In your answer, there is r, right? So new data, logically, new data we used to find u. Yes. So do it. Hmm. Use this a new story to find u. ඉතින් කල්පනා කර කර ඉන්නේ ෆෝමියුලා තාට යන්න ටක් කරලා කරගෙන හිත හිතින් දෙන්නේ නැහැ හිත හිතින් දෙන්නේ නැහැ කරගෙන යන්න ඕන ළමයි ටක් ගාලා කරගෙන යන්න you have a plan කරන් පස්සේ ආ හිත හිතින් දෙන්නේ නැහැ ටක් ගාලා කරන්න ඉස්සර කොයි පැත්තට දාන එකද හොඳ ඉස්සර දාන එක හොඳයි මේ පැත්තට because the equation is simple from that you can derive t in that t you apply for the vertical motion horizontally you apply only one formula which is horizontally apply only s equals to t apply horizontally s equals to t. This is r minus x. R minus x is there in your answer. Equals ut. So you get a very simple equation. T equals r minus x over u. Then apply vertically. D equals V, T is R minus X over U minus E over 2 square of this. r minus 6 squared over u squared. From this we have to find u. මෙතන තව කරදරකාරයෙක් ඉන්නවා. කවුද? We want to find u. තව කරදරකාරයෙක් ඉන්නවනේ මෙතන. කවුද? Yeah, it is v. The other thing is u is in the denominator. Basic mathematics. That will take 2 steps. In one step you can multiply everything by u squared and better we multiply everything by 2u squared. Will be much better. Multiplying by 2u squared, everything by 2u squared, you get on the left 2u squared h equals 2uv r minus 6 minus g r minus 6 squared. We want to find u. Then we will get කරදරකාරය ඉන්නවනේ. මොකද ගන්න? ඒකල හැමතිස්සෙම උදව් දීලා පාර පෙන්නලා තියෙන්නේ. You just have to follow that. Yeah. You want to get rid of v, right? But we already have an expression for that. This whole thing uv we can replace by gr over 2. This can be replaced by gr over 2. Substituting from 2. දැන් ඉතින් අහලා උත්තරේ දෙන්නේ මම ටක් ගාලා ගන්න. You can take r minus 6 out. R get cancelled, so you get x times r minus x. So u is equal to square root of x into r minus 6 divided by 2h. Then you substitute in technically you get the answer. You get t equals r times now ඔලේ හිට ගන්නවනේ square root of 2h. Yeah. Very well. G වලට මොකද? FG. You take GR. G into r. Give the answer. What? You can't very cut. Huh? Okay, Varuna, you can go to question number 5 of the tutorial. Christmas paper. Not from a past paper, right? You try question number 5 after this. Okay, then go to question number 5. These are the questions. You have to apply formula. Say from O to P first and derive some equation. Can you give me? Can you give me? We need some angle also. Alpha. Kira-kira ano naman? Ikaw malang hindi pa? Ukuran ko lang hindi na kira-kira. All connected. Right. Connected in our time. Where do you make this? And this. Right there. You first consider O to P motion, then apply formula. May karan natin na naman. O to P motion. So first we apply in this direction. S equals ut. S is A. U is U cos alpha. T. We can derive T from this and then applying it in the vertical motion. S equals ut plus half a t squared vertically. For T we can substitute from this. making T the subject, A over U cos alpha. මේවා කරන් ගියා නේද? දැන් ඉතින් මේව කරගෙන යන්න පුළුවන් වෙන්න ඕනේ. දැන් ගොඩක් හදවලා තියෙන්නේ. By now. So vertically applying S equals ut plus half at squared. S is again A, U is U sin alpha, T is this A over U cos alpha minus G over 2 T squared. Square of this A squared U squared cos squared alpha. You can simplify this a bit. A will get cancelled. So with U here, it gives like 1 equals tan alpha minus GA over 2U squared. We have here tan alpha. Here you are getting 1 over cos squared alpha. මතක් වෙන්න ඕනේ. මොකද කරන්නේ? Is a bit this is something very important, right? That you meet over and over again. What do you do? We have tan alpha here. Yeah. And here we are getting 1 over cos squared alpha. Oh, come on. How many diagonal? That's all. What do we do? Any idea? ගෙදර ඉනම් බලන් ඉන්න අය මොකද කියන්නේ? Yeah. ගෙසට් කතිය වැඩ කරා. එක එක ජාතියන් කියනවට කරදරයිනේ නේද? මොකද කරන්නේ ළමයි? Once you come up to this, this part use tan alpha, and here we are getting replaces by sec, then by tan. Yes, Abhita. First replace it by sec squared alpha, then by tan squared alpha. So take a thing in on. So you get like an equation like 1 equals tan alpha minus GA over 2U squared 1 plus tan squared alpha. That's number 2. Then how many unknowns are there in this equation? How many unknowns are there in this equation? 2. What are them? Yeah, U and alpha. Yes. We have an equation. We derived an equation with some effort, but it has 2 unknowns, U and alpha. So can you find any of them? No. Then what is the other? What do you do then? කියන්න බලන්න ළමයි මොකද කරන්නේ? අපි වහන්සේලා හොයාගත්ත equation එකක්, it has 2 unknowns. Now what do we do? This equation has 2 unknowns, U and alpha. with one equation, right? If there are 2 unknowns, what do you do now? What do you do next? Okay, correct. Use the other data, yeah, of the point Q. Yes, Abhita. Yeah, you can derive a similar equation taking the other point Q. චක්කල කරගෙන හැමෝම වේගෙන් කරගෙන යන්න ඕන ළමයි. බල බල ඉන්න බෑ. ටක් ටක් කරගෙන. You know what to do. You have a plan. ඒකට වෙලා යවන්න බෑ. This what I get. එකක් විතරනේ. Yeah, 1A got cancelled, but 1A remains at the last. Now we have two equations with two unknowns. Two equations are 2 and 3. Equation number 2 and equation number 3 are the two equations. Now how to solve them? How am I going to solve? कोई बात ఇప్పుడు u alpha දෙක මිතුර වෙනවා නේද එකක් අයින් කරගන්න එපා in two equations there are two unknowns you have to get rid of one to find the other කියන්න බලන්න මේක O level ප්‍රශ්නයක් මං අහන්නේ two simultaneous equations what do you do to solve them ලේසිම පාර dividing again only one will get cancelled everything will remain again the two unknowns will remain tan alpha u if you want to divide you can do it one way if you want to divide and get rid of something multiply the first by 4 yeah hari abhi hari so you can get rid of this whole part here everything is the same but you have 2 here and half here to get rid of the whole part you multiply this by 2 and subtract in 1 minute you can get the answer hari abhi 2 into 4 minus 3 so that will give 4 minus 1 on the left that gives 3 equals make this whole part will disappear and on right it will be 4 tan alpha minus 2 tan alpha මේ බලන්න විනාඩිය කියන්නේ හරි පාර ගියොත් ඒව තමයි දැනගන්න ඕනේ විභාගය ගියාම දුර පාරෙන් ගිහිල්ලා වගලා යවාගෙන අන්තිමට සංකීර්ණ නිසා වරද්දගෙන එහෙම වෙන්න පුළුවන් හොඳට මොලේ පාවිච්චි කළා කරොත් පොඩ්ඩක් කරනවා 1 minute very simple minimum risk of errors so tan alpha equals 3 over 2 or alpha equals tan inverse you have to find the angle it's tan inverse 3 over 2 right whether we need to find u what do you do we need to find u also in the question you have to find the angle and the speed now to find u what do you do correct and then we have the value of tan alpha this substitute this for this the value of u so substitute this we will substitute into substituting in say 2 if 1 equals 3 over 2 minus g over 2u squared plus into 1 plus 9 over 4 dA over 2u squared 13 over 4 equals half. U squared equals 13 AG over 4 u equals square root of 13 AG divided by 2 you take the positive answer right if not you get a negative one or taking the square root There will be two answers, but we take only the positive one, rejecting the other. And that's what we asked to show also. Just to find out, show that this is the answer. ඉවරද ළමයි? මොකද උනේ යුත්මි? නිින්ද ගිහලා එහෙම දින්නේ? ආ නේදවද? So now we go to a different type of problem. Do you remember at the beginning in theory? In theory, we said to find the maximum horizontal displacement of a particle. No? First, we said you have to project it at 45 degrees. Hmm? You project at 45 degrees to get the maximum horizontal distance. But saying so, we added two conditions. So it is valid only under the two conditions, which are number one, uh, the particle can have only the inclined velocity. The velocity inclined to the horizontal only. There can't be any other velocity component. So if so, if you have another velocity component, then the horizontal displacement, the maximum horizontal displacement, you can't say it's given at given by 45 degrees, projecting at 45 degrees, right? So you have to find the angle for the moment if there are other velocity components. Condition number two, the projectile has to be on the same horizontal level, right? It should be in a horizontal plane, right, at the same level. So if the particle is the projectile is not in a horizontal plane, it's in some inclined plane. For example, firing a bullet from the ground level to an aeroplane, targeting an aeroplane. So in that case also, you can't say to hit the aeroplane at the maximum distance, horizontal distance. The bullet has to be fired at 45 degrees, right? Remember? Right. Now, in these two cases, special cases, if the particle has other velocity components other than the original inclined velocity. So how to find the maximum horizontal displacement, or and also the angle which gives the maximum horizontal distance, right? The other case, if the particle is not in a horizontal plane, right? Not in a horizontal plane, how to find the maximum horizontal distance in that case, right? And what is the angle? How to find the angle which gives the maximum horizontal displacement? So we have those two questions to find answers. Uh, Now we will find the answer for the first question, right? In a past paper question. ඔකොල්ලෝ දෙනවා මම කරගෙන යන්න. ටිකක් දුර මම උදව් කරන්න අවශ්‍ය දැන් තාම. Question number 10. It's from 1991 paper, A-level paper, right? It's about this thing, right? The particle having some other velocity components. Hari කරගෙන යන්න. Question number, I said 10, 1991 paper. Question number 10 කරගෙන යන්න බලන්න. Cute. Question number 10. කරගෙන යන්න මොකද? First part එක උඩ කොහොමද කරන්න පුළුවන්? This question I gave you to like we discussed this earlier last year also. Now solving some problems of projectiles, not some, in fact many problems of projectiles, we derive a quadratic equation, right? In these two also, we derive in fact two quadratic equations of tan alpha. So theory of quadratic equations is very important in problems of projectiles. ඒක අදට වඩා අද පුළුවන් වුණ බලමු නැත්නම් ලබන සතියේ පාඩම ඉවර කරන්නේ explaining that further, right? How the theory of quadratic equations we connect with projectiles. We have seen already a few occasions. In this particular, we derive a quadratic equation and solve it. ඒක දැක්කම දැකලා තියෙනවා, but further details we will see next day, if not today. There are different other. Okay, again, ano ba? ඔකුලෝ තවදයක් තේරුම් ගන්න ඕන අපි මේ විභාගෙට පාඩම් කරනවා ගණන් හදනවා නෙමෙයි. මේ ලස්සන දේවල් ඉගෙන ගන්න ඕනේ. ප්‍රැක්ටිකලි දුර පයින්න කෙනෙක්ට වැඩිම දුර පයින්න නම් ඇන්ගල් එක මොකක්ද? එයාගේ ස්පීඩ් එක, එයා ගන්න ඉන්ක්ලිනේෂන් එකයි නේද? That is depends upon them. Anyway, now we have a way of computing it. Okay, ඒ අනුව බලලා ලස්සන දේවල් මේක ඉගෙන ගන්න. The long jump. Two velocities. One from the jump at the takeoff. There's another component from the run. As the long jumper runs in to the boat, at the takeoff, or some component of horizontal velocity will remain. This under u. Lambda u is the inclined velocity with the jump, and from the run remains some velocity u, component u horizontally. That's a given. Say taking off at the point A and landing at some point B. We want to find this horizontal distance, displacement L. You know very well how to do that, right? First apply vertically. S equals to t plus half a t squared. Find t. then apply it horizontally, you get an expression for L. Vertically only lambda u sin theta is the velocity, because this is horizontal, it has no effect uh, considering the vertical motion. Lambda u sin theta t minus go2 t squared. The t will get cancelled. You can cancel it saying t is not equal to 0. So the value of t is given by 2 lambda u sin theta over g. So this is the time, right, for the flying time. That's the flying time for the total motion. Then we'll apply it horizontally. S equals ut. L is given by S is equal to L, and U is the horizontal component of velocity. So there are two parts, U plus lambda U cos theta. Uh, the velocity horizontally is U plus lambda U cos theta, cos alpha rather, and T is given by this. That has to be alpha. Theta given in the question. Okay, I'll take theta. Lambda U cos theta, and T is given by 2 2 lambda u sin theta over g. I think we have the answer here for the first part. You take u out, continue the u squared everything. Here is a u, and there is another u. Can take u out. 1991. Yeah, 2 u squared lambda og. It is there. You take the u out. So we have 2 u squared lambda over g, and within bracket it's 1 plus lambda cos theta. That's question number 1. And that's the answer for the first part, right? ඔබට උත්තරේ ගත්තා නේද ළමයි? First part. That's the second part. In the second part, you have to find. You are given lambda equals 1, and to find the angle theta, you have to find the angle theta for which L is maximum. Then the question is about that angle theta, right? For that theta, we have to find the relation of maximum height and the displacement. But before anything, you need to find the angle theta, for which angle theta, then the maximum horizontal displacement, first angle theta, for which L is maximum. But before that, lambda equals 1, shall we use that? Apply it. Lambda equals 1 gives L equals just 2u squared over g, 1 plus cos theta. There should be a sin theta also. 1 plus cos theta into sin theta. Now we want to find the angle theta for which L is maximum. What do you do? Now this is a question, right? Real question that we have in this problem. Now 45 degrees. Do you say L is maximum? Can we say L is maximum at theta equals 45? No, it is not valid here. So you have to find it at the moment. The angle theta you have to find at the moment for which L is maximum. So what do you do for that? To find angle theta for which L is maximum. මොනවාද මතක් වෙන්නේ? ඉගෙන ගත්ත දේවල් මතක් වෙන්න ඕනේ. What is it? In one word? To find theta for which L is maximum. What do you do? වචනෙන් කියන්න පුළුවන්. ඉගෙන ගත්ත දේවල් අපි මෙතනදී සම්බන්ධ වෙන්නේ කොහොමද? We want to find the angle theta for which L is maximum. මොකද මතක් වෙන්න ඕන? කියන්න බලන්න ළමයි. ඉගෙන ගත්ත දේ වෙලාවට මතක් වෙන්න ඕන. නැත්නම් ඉතින් අර යුද්ධෙට නැති කඩුව වගේ තමයි. Yeah? No. They'll give the same distance. මොකද කියන්නේ ළමයි? So we talked a lot about maximums and minimums earlier. Where? Maximums and minimums. We talked a lot about them. Where and when? It's in differentiation. Don't you remember when we were doing drawing graphs? Drawing graphs, we talked a lot about maximums and minimums. So what is the requirement for a maximum or minimum? Requirement is if y is a curve of x, y is a function of x, for a maximum or minimum, the requirement is අමතකයි නේද? ටක්කලා මතක් වෙන්න ඕන. If y is a function of x, for the graph, for the curve to have a maximum or minimum, the requirement is මෙච්චර අමතකද? ඒ කොහොමද? The requirement is dy by dx equals 0. You find dy by dx and set it as at 0 to find whether there are maximums or minimums. Here this is not the story y is a function of x. Instead it's a you have L is a function of what? L varies with what? Theta. L is a function of theta. So for maximum or minimum L, the requirement is dl by d theta equals 0. So we find L dl by d theta, then set it at 0 to find the angle theta for which L is maximum or minimum. But before that, do we differentiate it, keep it like this. It's a product. Differentiating a product and equating 0, more work. But you can make it easy just by open the brackets. You can make it as an addition. Then you get sine theta cos theta. මෙතන දෙක පුත් තියෙනවා 2 sin theta cos theta. That can be replaced by here. Expanding this, you get L equals u square over g 2 sin theta plus 2 sin theta cos theta. Make a name the right to differentiate as a product. But you can replace this by u square over g 2 sin theta plus this is sin 2 theta. Now things are relatively easier. Then again you find dl by d theta. Then for maximum or minimum L, it is should be equal to 0. You can find theta. Again that mangala then. ini use करो mana kidding with you? Nothing differentiating with respect to the hearing. Like I was, they don't feel. So maximum or minimum dl by d theta is equal to 0. So L max के लगा हमने तो L max dl by d theta equals 0 and gives 2 cos theta plus 2 cos 2 theta equals 0. Make happen on cos 2 theta equals minus cos theta. So minus cos theta we can write. General solution here when the cos is not 0, right? We are finding a single angle. So minus cos theta you can write cos of phi minus theta. So equating you find just the first angle. So theta equals pi by 3. This is the angle for which it is maximum. Hmm? Now for this angle we have to find the ratio of L and H. H is approximately equal to maximum height. You have to show that maximum height is approximately equal to the distance L max over 7. So for which you need to find L and H corresponding to this angle theta. Ito ko yan, kalog 3 lang pala. For theta equals pi by 3, find L, find H, and see the ratio of them. So anyway, this is the angle which gives the maximum length, right? Okay, then you can advise your friends to jump at. You have to calculate the angle at the moment, right? And advise this is the angle that you have to jump to get the maximum jump. Okay. Uh, then find L and H. I mean, so what is L? To find L, you can use this. This even this. Shall I use this? Number two by 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 two by two. You get L max. L max equals u square over g. U square over g 2 sine pi by 3 plus sine 2 pi by 3. So that's u square over g. 2 sine pi by 3 is just root 3 plus sine 2 pi by 3 is root 3 over 2. It's finally the maximum distance is given by maximum horizontal distance is given by you get like 3 root 3 over 2. 3 root 3 over 2 u square over g. This is the maximum horizontal displacement. පයින්න පුළුවන් වැඩිම දුරවක තමයි. දුර පයින් එක්කනවා. Now we have to find the maximum height matching to this angle. Hmm? You know very well how to find the maximum height. For the maximum height, මට diagram එක මකලා තියෙනවා. For the max, for the maximum height. Say it's from A to C. Yeah, ඔකලගේ diagram එක දාගන්න. H A to C U and alpha. This height H. So A to C, then A to C motion. Apply vertically v square equals u square plus 2s. That's what we do normally to find the maximum height. V is 0, u is it's lambda u, but lambda is equal to 1. So u sine pi by 3 when lambda is equal to 1 square minus 2gh. You get h equals u square sine pi by 3 is root 3 over 2. That's 3 over 4 further divided by 2. So that will give 3 over 8g u square over g. Are they? So that's what we get for maximum distance and the maximum horizontal distance and the maximum height. Now we need to express L in H. Oh no, H in L. Not find H in terms of L. So better we divide 4 by 3. 4 over 3. You can get H in L. H over L equals on right u square over g will be cancelled. So with this 3, you get like you get like 1 over 1 over 4 root 3. This what you get dividing them. Galan, how do you get? So 4 root 3, what is it approximately? H over L equals 1 over 4 root 3. That's what I get. For root 3, you can approximately root 3. What do you apply? Approximately it is like 1.71 1.73. 1.73. Okay, root 3 is approximately 1.73731. Another here in 6.9 something, so approximately 7. So this is root 3 is approximately 6.92. It is 6.92, approximately 7. So it is equal to approximately equal to L over 7. Right? Right, tapi kalau dia ada gunakan Latino. Hari, E number. This is usually how we find the maximum horizontal distance if there is another velocity component. So this happens practically always, right? Almost everywhere. මොනවද පක්ෂොට් එක දාන්න කියොත් නේද? නිකන් ඉඳලා කොහොම දාන්නේ නැහැ. මම එකක් කිව්වේ. අර නුවර වැලේ බලන්න ගියාම මම මාළුන්ට මොනවද බනිස් දානවා වගේ. මෙහෙම දාන්නේ නැහැ. වට දෙක තුනක් කරකිලා නැත්නම් දුවගෙන ඇවිල්ලා පණ දාලා නේද? විසි කරන්නේ. පාස් බෝල කෙනෙක් එක තැනින් ඉඳන් ජබුක් කියලා බෝලේ දාන්නේ නැහැ නේ. එහෙම නැත්නම් ජාවලින් ත්‍රෝ ඔය හැමතැනම තියෙනවා මේ කාර්තුන්දරේ. In addition to the inclined velocity, you have another horizontal velocity component giving to the particle. So now we know how to solve that problem, right? If the particle has some other velocity components, so just differentiate, get an expression for L in terms of theta, differentiate dl by d theta, set it 0, then you can find the angle for which the horizontal distance is maximum, and then you can find the horizontal distance also, right? So one type of problem we solved now. There's another type. If the particle is not on a horizontal plane, not in a horizontal plane, in an angle inclined plane, how to find the maximum horizontal distance, right? All right. Then in that problem, right? To find the maximum horizontal displacement if the particle is not in a horizontal plane, and in some other problems also, we use our knowledge of quadratic equations, right? Quadratic equations, we have already used the theory of quadratic equations in these problems, but not one thing we have seen so far, the delta theory. To find the condition for real roots, delta is greater than or equal to 0. We haven't used it yet in these problems. Now we are going to see how it is used, right? Put it on failure sentence. අද එක පටන් ගමු ලබන සතියේ මම හරියට විස්තර කරන්න. मैं note कर लिया क्या? I'll give question also question कर लिया क्या? हाँ example लेगा. Right. To solve some problems of projectiles and use the condition delta is greater than or equal to 0 for real roots. Alright. Working. Example है क्या करना होगा? ठीक है नहीं लगता है. On the Ghana clear करना it was a patanga. You know what to do. Here we stated it here, right? So you derive a quadratic equation, then apply the condition delta is greater than or equal to 0 for real roots. There are two ways of getting the quadratic equation, right? One way is the quadratic equation of tan alpha. You have seen it many times now. The other is the quadratic equation of x, the horizontal distance. Take it up question here in this tan alpha, right? Quadratic equation of tan alpha. First derive that, then apply this requirement. කරගෙන යන්න බලන්න දාන ලියාගෙන කරගෙන යන්න බලන්න. කරගෙන Get a quadratic equation. We first apply horizontally. O equals U cos alpha t. T equals OA over U cos alpha. Apply vertically. 3A equals U sin alpha. T is this. Minus G over 2 T squared. 16A squared over U squared cos squared alpha. So we see several things. Simple A get cancelled. Then U get cancelled here. The 3 equals 4 tan alpha minus minus 8 AG over U squared sec squared alpha. And the next step to replace sec by tan. 3 equals 4 tan alpha minus 8 AG over U squared 1 plus tan squared alpha. බලන්න මෙන්න මෙතනට ආවද කියලා. මෙතනදී මට හැබැයි මෙහෙම වැඩක් කරන්න තිබුණා. In the expression that we need, there is a k, right? K is equal to U squared over AG. K equals U squared over AG. Now you can introduce it here. මෙතනදීම දැම්ම නම් ඉවරයි. U squared over AG meeting. This is 1 over K. දැම්ම දාගත්තා නම් ඉවරයි. නේද? In the expression that we need, there is a K. So this is 1 over K. But we do it here. Introduce it here. Then බලන්න මෙහෙම එකක් වෙනවද කියලා. 3 equals 4 tan alpha minus 8 over K 1 plus tan squared alpha. I can multiply it by K. 3K equals 4K tan alpha minus 8 tan squared alpha. And finally, the quadratic equation I get is this. Taking this to the other side, 8 tan squared alpha minus 4K tan alpha plus 8 plus 3K equals 0. This is the quadratic equation that I get. බලන්න ඔයගොල්ලෝ ඔතනට එනකන් ආවද කියලා. This is the first stop of our journey. Hmm? Then, what is the next step? After this quadratic equation, next step is scalar theory. ඇයි අපි නෝට් එක ලියලා කිව්වේ? මොකද කරන්නේ ඊළඟට? Once we get to this quadratic equation, then we apply the condition that delta is greater than or equal to 0 for tan alpha to be real. Right? That is the requirement for real tan alpha. Tan alpha to be real. The requirement is delta is greater than or equal to 0. B square is 16k square minus 4, A is 8, C is 8 plus 3k is greater than or equal to 0. You can divide everything by 16 and give 2. So k square minus 6k minus 16 is greater than or equal to 0. This is the answer. Then you have to find the minimum possible value of u. But once you come up to this, u disappear. This is an inequation. ඒකේ නම් මම homework වලට ඉතුරු කරන්න. අපේ වෙලාව අද පැය දෙකක් හරියට. මට මතක් කරන්න ඕනේ. last part of this. ඒක මම homework වලට කියන්නේ. පොඩි දෙයක් තියෙන විනාඩි දෙකයි. එතනට ඔයගොල්ලෝ කරන්න බලන්න. ඊට පස්සේ basically පාඩම ඉවරයි ළමයි ආ. මම ඊළඟ දවසේ මම මේ තව ප්‍රශ්න ටික ඩිස්කස් කරන්න. You have to do all the parts of the tutorial, the remaining parts, right? The tutorial, then all past paper problems from 2001 to 2005. Homework මේකත් ඉවර කරන්න ඕන. homework tut එකේ මොනවද අපිට ඉතුරු? අපි 6 7 8 ඒ ඔක්කොම කරන්නේ. 5 6 7 8 9 කරේ නැහැ. 9 10 11 තියෙනවා තමයි. 9 10 11 10 කරලා තියෙනවා. to 9 and 11 remaining. 9 and 11 from the tube. Then past papers, A-level ගණන් තියෙනවා from 2001 to 2005. ඔටික් කරන්න ඇති. මොකද එතනින් එහාට හොයාගන්න අමාරු වැඩි නැහැ projectiles. first paper එකේ දීලා තියෙනවා පොඩි පොඩි ඒවා from ආ table එක දීලා තියෙනවා පොඩි පොඩි ඒවා from 2011 onwards. ඕකෙන් ගණන් කීපයක් මම ඊට පස්සේ ඩිස්කස් කරන්නම්. දැන් අහන ප්‍රශ්න වලට වඩා ටිකක් ලොකු ඒවා අපි මේ කරන්නේ ආ. ඒකට කමන්නේ. ඒවා ඉගෙන ගන්න දෙපයි. හරි නේද ළමයි? ඔය ගණන් ටික හදන්න මේකත් තව පේලි දෙකයි ආ. ඒක ඉවර කරන්න. අපි එහෙනම් ඔතනින් ඉවර කරමු හන්තිය. right? රිවිෂන් papers කරලා එවන්න ඉක්මනින්. මට දවස් දෙක තුනක් ඇතුළත කරලා එවන්න paper එක දාලා ඇත්තේ quadratic equations. ඒක කරලා එවන්න මේ මම ඒව බලන්නම්. From next Saturday we will start to discuss them, right? Next Saturday at 6 o'clock we will discuss them via Google Meet, right? හරි. එහෙනම් ඔතනින් නවතින ළමයි ඔයගොල්ලෝ හැමෝටම බුල්සන්නයි. Not 6 a.m., 6 p.m., right? From next Saturday, 6 p.m. උදේ ආයෙත් මම මම නැගිටිනවා ආයෙකට. මට වැරදුනානේ 6 p.m. right? From next Saturday. ඊට කලින් මට එවන්න answers හැමෝම. හරි අපි ඔක ඉවර කරමු. 6 p.m.